Hi everyone, this part is on carboxylic acids and their derivatives. What we mean by derivative is that they can be from carboxylic acids. I can do reactions to form any of these kinds of flavors of molecules, different functional groups. They're sort of like aldehydes and ketones are thought of in the same sort of class because they have carbonyl group. These have a carbonyl, but they also have something else special about them. So like they all have carbonyl, but they have an OH, or they have an NH, or they have an OR, or they have a halogen, or they've got some other group. They tend to be higher oxidation level, like carboxylic acid is more highly oxidized than an aldehyde. Yeah, usually I think of it as a carbonyl with something else, usually a good leaving group sometimes, or not good leaving group, but oxygen, nitrogen, halogen, something else other than carbon and hydrogen. Okay, there's a lot to say about that. Okay, so our goal right now is just learn the different functional groups and their names, because it's been a long time since you've learned all the functional groups. You probably forgot a lot of them. Just learn your carboxylic acid. Know that one pretty well already, I'm sure. Acid halides, I don't think you know as well, other than through Friedel-Crafts acylation. You used acyl halides then. We call them acid halide or acyl halide, acyl referring to the carbonyl group with the R group. Acid anhydride, pretty sure you've never really, even though you've used it in lab maybe a couple times, probably not too familiar with acid anhydrides. So take a moment to learn what an acid anhydride is, a carbonyl with an O, C double bond O, R group. An ester you're pretty familiar with, but an amide, I think I would review that because you probably haven't seen that so much right now or up till now. Okay, so first just learn these functional groups. If you see a molecule, can you identify if it's an ester, an amide, acid halide? Okay, and sometimes it's best to use flashcards and just look at a structure and say, oh, that's an acid anhydride. Okay, so you want to have that level of identification before you move on. Once you know those different distinct functional groups, then you want to start being able to name them. Unfortunately, we're going to do all the naming together because it's all in the same chapter. So really get to know each one by itself and then put it all together at the end. All right, so let's do that now. I'll just give you a quick overview of naming for each group, and you can spend more time on your own practicing it. Okay, what I recommend when you practice it is to note what is the ending. Well, first, what is the functional group? What is the ending for this functional group? And then how do I practice naming these compounds with that functional group? Okay, so for carboxylic acids, you'll notice the ending is always the word acid, but it always ends in an IC, something ic acid. Okay, so, and sometimes it's oic acid, and sometimes it's ic acid. So ic or oic acid is the ending for carboxylic acids. There are some that have a historical name to them. So like formic acid, something that is associated with ants, and it comes from the Latin for ant. Okay, A-N-T. Okay, so a lot of times these are compounds before we even knew the chemical structure. They're tied to things like caproic acid is like from goats, like it's from goat milk. So, you know, so we use the names historically from like things where these compounds were found in nature. But through IUPAC nomenclature rules, then a systematic naming, you know, you don't really want to have names like that, I guess, if you want to be able to name things systematically, because common name and historic names are things that have to be memorized, right? So here, instead of formic acid, the common name, we use methanoic acid as well. It just means one carbon. So making a carboxylic acid out of one carbon. Acetic acid, you're very used to that term, that word, that name, but we also call it ethanoic acid. That is a systematic name. Propanoic, sometimes we call it propionic acid. So just they're similar enough that usually that's not a problem. Butyric acid is sort of a common historical name, but we also call it butanoic acid. So when they're listed twice like this, just be familiar that it can go either way. You should be familiar with both ways. Okay, and finally, how to name things. We use the same kind of naming system as always. The carboxylic acid will have the priority over everything you've learned so far. This is a 5-phenyl 4-hydroxy hexanoic acid because it actually is numbered to 6 up here. Methylhexane dioic acid, so this has 2 carboxylic acid groups, so it's a dioic acid. All right, so for all examples, go through them, make sure they make sense to you, and then answer some special questions like acetic acid. I want you to know this is an acetyl group. That's really important for you to know. You always hear about things like acetyl-CoA when you learn about Krebs cycle, so I want you to link that with an actual structure. So acetyl, acetyl, that means 2-carbon carbonyl unit. Okay, so 2 carbons. All right, let's name these carboxylic acids. Go ahead and pause it and give it a try, and we'll check our answers. All right, for these, I've got 3-bromobutanoic acid. For this one, benzoic acid, we actually can count it at 1 here. So 1, 2, 3, 3-hydroxybenzoic acid. That's an exception where you don't count this carbon because it's already in the name, benzoic acid. And then this one is a hexanoic acid with lots of methyls, 3,3,4,5 tetramethylhexanoic acid. The name of the conjugate base of a carboxylic acid has the ending 8. So what would it be? Like, for example, here, 3-hydroxybenzoic acid. If I took this H away and made it negative, that would now be called 3-hydroxybenzoate. Okay, so just FYI, you need to have a name for its conjugate base as well. All right, let's try esters now. Okay, esters are complicated because of this R group. If you look up here, esters have an R group here and they have an R group here. So that can get a little confusing. Which R group are we talking about? The one on the O, the one in the main chain? So here we usually have the R group on the O come first, and then we name the rest of it second with an ending for esters. The ending being 8, which we just learned up here, right? So this sort of is the basis of an ester right here. All right, so 8 or O8. And with experience, you learn when to use each one, 8 or O8. All right, so here's how we do that. Formate ethan acetate or ethanoate. When we use these IUPAC systematic prefixes, ethan, propan, pentan, we use O8 at the end. If we use a common name, formate acetate, we just use 8. All right. Okay, esters have 2 R groups, so which one comes first? Well, I just said it. It's the one on the O. So I always name that one first. So for example, this one, 1, 2, 3, 4, butyl, and then 1, 2, 3, propanoate. Propanoate is a 3-carbon ester with the carbonyl portion. This butyl part comes before. Okay, so you'll see that example in all of these. So go ahead and go through the rest of these examples and try naming these. Okay guys, for these, naming the R group first, it's phenyl, then there's a space. That's another thing, these are actually 2 separate words. Then propanoate. This one is a 1, 2, 3, 4 dimethyl, but I have to name this methyl first, methyl space, 3, 4 dimethyl. Then this whole thing is a benzoate, right? Right here, it's just like benzoic acid, benzoate. And then here, I'm using this as a template up here. This is a 1, 2, 2-chloroethyl. So I'm saying this is a 2, 2, 2 trifluoroethyl space, and then 4-methyl pentanoate. O8. There we go. Ester. Pentanoate, not pentenoate. Pentan. There, okay. All right, so good. 2 down, only 4 more to go. I don't know. There were a lot, right? 1, 2, 3, 4, 5. Okay, 2 down, 3 to go. Acid halides or acyl halides. Okay, these are can be any halogen here. I'm using chlorine or bromine because they're the most common in synthesis. All right. Same thing, one carbon, common name is form, so formyl or methanoyl for a systematic name. Acetyl or ethanoyl. Benzoyl, butanoyl, hexanoyl. All right, so the ending is oil. Really weird. Okay. And with the oil ending, then we name the halogen last. Okay? Go through these examples, make sure they make sense, and then try naming these. All right, so with just a carbon here, then let's name this guy right here. So this will be a 1,2 unit. So that's an ethanoyl or acetyl. This is a 2-phenyl. Acetyl or ethanoyl. Okay, bromide. Okay, so sort of weird, probably totally not used to that. It's probably freaking you out right now, but that's how we name them. Okay, so same thing here. This is a benzoyl, okay, so benzoyl chloride, but just like benzoic acid, benzophenone, it's got a benzene ring here. But you've got a methyl group here, so that's in the 4th carbon. You could call it para, or you could call it 4-methyl, and that's a 4-methyl, and this whole thing right here is called a benzoyl, and then chloride is the halogen we're using. Benzoyl chloride. Okay, and then sort of benzoyl, you probably heard like a, what's that called? Proactive, the acne medication is called, benzoyl peroxide is the main ingredient in that. This is a 1, 2, 3, 4, 5. So pentanoyl chloride, but we've gotten several groups on here. So 3-chloro, 4-methyl, pentenoyl, so pent-3-enoyl chloride. And do we need E or Z? We do need to know, no, we don't need to know, because this and this are methyl, so it's symmetrical, so we don't have an E or Z. But if there wasn't, we would need an E or Z or cis or trans. So pent-3-enoyl chloride instead of pentanoyl chloride. So for acid anhydrides, we name these two R groups, and when they're the same, it's symmetrical. We only need one name. Acetic because of the 2 carbons there, or ethanoic, right, is the other way we can say that, ethanoic anhydride. Propionic, I think I'm missing an IR. Propionic anhydride, okay, or propanoic is also fine. Propionic or propanoic. Acetic and propionic acid anhydride, okay? So these, you have to name one and the other, and it's alphabetical. Okay, so suffix ending used is just like with carboxylic acids, ic or oic. And the symmetrical ones are where the R groups are the same. So go ahead and practice with these. Okay, so for these, pretty straightforward. Okay, acetic or ethanoic, and then that affects who comes first. So this is butanoic, all right, or butyric. Butanoic, ethanoic, anhydride, acetic or acetic, butanoic, anhydride. Ugh, hard for me to say. Benzoic, okay, just like benzoic acid, but it's an anhydride. So benzoic anhydride. Benzoic again, and propanoic. So benzoic, propanoic anhydride. All right. Last one, okay, amides. Amides are a little complicated because they have R groups as well. Some of them can be on the N, or some of them are on the main chain. So if you just have a simple amide, so the nitrogen doesn't have R groups on it, then you just call it an whatever amide, an alkyl amide, methanamide, ethanamide. Okay, try these down here. And then there's one more little thing to do, of course. All right, pause it and give these a try. All right, so the first one is a 3-carbon unit, so just simply propanamide. Really nice and easy. Nothing on the N, so I don't need an NN anything. This one though has something on the N, so this is an N-phenyl, so N-phenyl group, and then I go with the propanamide or amide. And then here, this is a methyl and a methyl, so N-dimethyl, and then this is either acetamide or ethanamide. And then dimethyl ethanamide. Okay, all right. So next ones are simply, how do you name carbonyl as a substituent, as something off the parent chain? So if I had an extra carbonyl, I would just name that as an oxo group. So here I have an aldehyde versus a carboxylic acid. Carboxylic acid is higher oxidation than aldehyde. So usually that tells me about priority. So I want to treat it like a carboxylic acid, not like an aldehyde. But I will have to name this C double bond O as a group off of that carboxylic acid. So I call it 2-oxo, and then whatever name that would have as a carboxylic acid, which is acetic acid because it's 2 carbons total. All right, so same thing here. An amide is higher oxidation than ketone, so I would call it by an amide name. 1, 2, 3, 4, 5. So pentanamide, where there's an oxo group at carbon 4. So the prefix used is oxo, and it's a prefix because it's considered a substituent, similar to how an alcohol group as a substituent is called hydroxy. So draw the following and give those a try, and we'll check our answers. All right, so here's what I got. Butanoic acid is carboxylic acid with 4 carbons, and then I did a 2-oxo. This is carbon 1, this is carbon 2. I worked backwards, so I did the pentanoyl chloride first, 1, 2, 3, 4, 5, and then I put the 3 and the 4 dioxo. Last one is a 3-carbon ester with a pretty involved ester R group here, so phenyl, the 3-chloro coming off of this O, because that came first in the name. Actually though, phenyl space 3-chloro, 1, 2, 3. I believe because this is all together, actually I was wrong, this chlorine should go on the end here. That's carbon 3. Okay, so I would probably need, if I meant chlorine here, I would have to say 3-chlorophenyl, or put that in parentheses somehow. All right, so there we go, 1, 2, 3. Okay, and 3-oxo propanoate, 3-chloro, 3-oxo propanoate. So I actually did 2-oxo. Making all kinds of mistakes. There we go. All right, so that's how that goes. So I think probably the hardest thing about this, I think any one functional group is really simple, but when you have all of them mixed together, you just really have to keep track of all these rules and what functional group you're even talking about and all the nuances between, or just different, plain differences between these. So here's some practice. What I recommend is you learn it by drawing first, then take those answers and work backwards. Cover up the names, figure out what would the names be based on your drawing. Then you'll have all the practice you need. Okay, so do those and give those a try.